everyone, welcome to today's lesson. In chemical production, on-site inspections occupy a critically central position, serving as the vanguard for ensuring production safety and stable operation. Through regular inspections, potential hazards, such as equipment wear, leakage, and over-temperature or over-pressure conditions can be identified in a timely manner, thereby preventing faults from escalating into major safety incidents like fires or explosions, and safeguarding both personnel lives and company assets. At the same time, inspections can detect abnormal process parameters, which facilitate prompt adjustments and optimization, ensuring a smooth production process and maintaining stable product quality, which is of great significance to the stable and efficient operation of chemical production. Next, we begin learning Scenario 7 of the fundamentals of modern chemical industry, on-site inspection. As you all know, chemical production is a complex and inherently hazardous process, and inspections are like the guardians of our chemical facilities, constantly ensuring the safe and stable operation of the equipment. Today, we will take the C2 hydroprocessing unit of a certain petrochemical company as an example to jointly study the inspection operations of this unit under normal startup conditions.
Chemical plant patrol inspection. The patrol inspection work in chemical plants, referred to as patrol inspection, means that a field operator carry various patrol inspection and measurement tools, and in accordance with the regulations of the 5-word patrol inspection method of look, listen, smell, measure, and record. They continuously patrol the production site of the plant 24 hours a day, repeatedly cycle to the designated positions according to a specific route and time, to record the main process data such as pressure, temperature, flow, and liquid level at the plant site, measure the operation data of various chemical static and dynamic equipment, and check the on-site instruments and the instrument data of the DCS system with the control room operator through walkie-talkies to confirm that the data of the same parameter are consistent and correct. In the 5-word patrol inspection method, look requires being observant. Field operator should be all-seeing and timely discover the leakage of equipment through the visual system. Judge whether the equipment is operating normally, according to the changes in the appearance, shape, position, and color of each component of the equipment, and check whether the parameters such as liquid level, pressure, and current are in a normal state. Listen requires being attentive. Field operator should be all-hearing. Capture abnormal sounds on the patrol route through the auditory system, and timely discover the leakage source of process media and the abnormal state of equipment operation. Smell requires being sensitive. Field operator should smell around through the olfactory system, capture abnormal odors on the patrol route, and timely discover the leakage source of process media. Measure requires being diligent in hands. Field operator detect and record the operation data of processes and equipment through various measuring tools, and predict abnormalities and hidden dangers by comparing the data before and after. Record requires being diligent in mind. First, remember the operation status of the previous shift and existing equipment hidden dangers, and have a thorough understanding. Second, remember the control indicators and real-time data of process equipment, and have a clear idea. Third, remember the treatment methods and steps for various accidents or hidden dangers in the post, and be prepared. In short, Patrol inspection can monitor the operation status of various process parameters and equipment, provide a basis for a control room operator to determine whether the measuring instruments are correct, timely discover the abnormalities and defects in process operations and equipment operation, handle initial hidden dangers and implement reports in the first time, and effectively prevent the expansion of the situation. Therefore, high-quality patrol inspection is the guarantee for the safe production of chemical plants.
This seemingly simple work actually encompasses many critical steps and requirements. First, inspectors must follow specific routes and schedules for the inspection to ensure that they can comprehensively and systematically check every key part of the facility so that no potential problematic area is overlooked. Let's take a look at the inspection route map for the C2 hydroprocessing unit. According to the roadmap, the starting and ending point of this inspection is the central control room, with the field operator departing from the control room, then sequentially inspecting the operating status of each dynamic equipment and the process parameters of the static equipment in the unit, and finally returning to the control room. This entire route covers the whole C2 unit, effectively ensuring the unit's stable operation. Second, on-site inspection is an operation that requires the collaboration of multiple personnel, usually carried out through the cooperation of field operators and control room operators. Field operators must strictly follow the inspection checklist when inspecting, and if any abnormalities are found, they must report them immediately and isolate the unit with warning tape and display a maintenance isolation notice. Inspection items can generally be divided into process data checks and equipment status checks. Process data checks are crucial for ensuring the stable operation of the unit, product quality, and safe production. For example, in the C2 hydroprocessing unit, during inspection, it is necessary to check key data in sections such as the reaction zone, the distillation section, and the storage area, such as the level flow, temperature, pressure, and vibration speed of various equipments. Inspection methods include reading on-site instruments, using measurement tools, and cross-checking between field and control room operators. Field operators compare the data they have recorded with normal ranges, and if abnormalities are found, they must analyze the cause and report it promptly for resolution, thus ensuring the safe and stable operation of the unit. Equipment status checks are essential for ensuring the stable operation of the unit, product quality, and safe production. For example, in the distillation section of the C2 hydroprocessing unit, the inspection covers equipment such as the distillation column and the reboiler, and the field operator must pay attention to the integrity of seals, the appearance, the operation of drive components, and the tightness of connection points. Inspection methods include visual observation, tool measurements, and cross-checking between field and control room operators, and if abnormalities such as leakage or excessive vibration are found, the cause must be analyzed and reported promptly for action to ensure the safe and stable operation of the unit. In addition, field operators must properly wear anti-static work clothes, safety helmets, safety shoes, and other personal protective equipment during inspections, and carry inspection kits, walkie-talkies, thermal detector, vibration meters, toxic gas detectors, sound rods, F-tap valve wrenches, adjustable wrenches, and other tools. With the continuous development of information technology, Electronic inspectors equipped with sensing and recording functions are gradually being applied in chemical plant inspections. Through inspection, if any equipment defects are found, those that can be resolved should be addressed immediately and recorded in detail in the inspection log. Any equipment defects that cannot be resolved by on-site personnel must be recorded in detail and reported up the chain of command, while also intensifying observation to monitor the development of the defect to ensure the smooth operation of the chemical unit. It is very important to verify the accuracy of process and equipment data. At this time, control room operators must continuously monitor DCS data in the control room and perform cross-checks between the control room and field operators. The cross-check between field and control room operators means that at the same time, the field operator compares the DCS display value of an important process parameter with the on-site instrument reading. By comparing the results from these two different measurement methods for the same parameter, to verify the accuracy and authenticity of the process parameter measurement, which is one of the effective means to detect potential accidents and diagnose instrument failures.
Control room and field operator verification. Control room and field operator parameter verification is a task where both operators simultaneously check the same critical process parameter, comparing the DCS system display value with the field instrument indication at the same point in time. By comparing the results from these two different measurement methods, the accuracy and reliability of the process parameter measurement can be validated. This serves as an effective means to identify potential hazards and diagnose instrument failures. Next, we will introduce the specific details of control room and field operator parameter verification during routine inspections along designated routes and at scheduled times. Field operators are required to record key parameters such as pressure, level, temperature, valve position, large-scale unit status, and motor current. These data are then reported to the control room operator via walkie-talkie. Control room operator compare the parameter readings on site with the display values in the DCS system to verify whether the data shown in the DCS falls within the allowable error range relative to the readings of the field instruments. Given that the same parameter is obtained from different measurement instruments, some deviation in readings is inevitable. Therefore, under normal circumstances, a plus or minus 10% error between the DCS display values and the field instrument readings is permitted, provided that the upward or downward trends remain consistent within the same time period. For example, when a field operator performs a routine inspection of a running pump, they promptly report the outlet pressure reading from the field pressure gauge to the internal operator via intercom. The control room operator then compares the reported value with the pump outlet pressure displayed on the DCS screen. If the DCS shows a pump outlet pressure of 0.4 megapascals, while the field pressure gauge reading reported by the field operator falls within 0.36 to 0.4 megapascals, the measurement error is within the allowable range, indicating normal operating parameters. However, if the discrepancy exceeds plus or minus 10%, it must be promptly reported to supervisors for further assessment and troubleshooting. Determine whether the discrepancy is caused by a malfunction of the pressure transmitter sending data to the DCS, or a faulty field pressure gauge, and then take corrective measures to ensure the accuracy and reliability of process parameter measurements. This concludes today's micro lesson. Let's summarize the key points. First, cross-checking between control room and field operator refers to the process where both parties verify the same critical process parameter. By comparing the DCS display value with the field instrument reading at the same time. This practice is an effective method for identifying potential hazards and diagnosing instrument failures. Second, under normal circumstances, a plus or minus 10% deviation between the DCS display value and the field instrument reading is permissible. Third, if the deviation between DCS displayed values and field instrument readings exceeds the permissible plus or minus 10% tolerance range, immediate reporting to supervisors is required for fault diagnosis and corrective actions.
You all know that chemical plant equipment comes in numerous types and quantities, and equipment failures can cause unforeseeable losses to the production process and production safety. Equipment inspection is an effective means to ensure the safe and stable operation of equipment, and it is the main component of on-site inspections in chemical plants. The dynamic equipment in chemical plants mainly includes rotating machinery and reciprocating machinery, such as fluid pumps, motors, fans, various control valves, and various types of large units. And during inspections, it is necessary to check for abnormal conditions, the integrity of sealing systems, cooling systems, control valves, operational parameters, motor systems, and lubrication systems of the dynamic equipment. On-site inspections typically use the look, listen, and touch method for focus checks on dynamic equipment. Look. Observe its operating condition and the status displayed on related instruments, such as pressure, temperature, oil level, etc. Listen. Listen to its operating noise to determine if there are any abnormal sounds. Touch. In conjunction with measurement instruments, feel for any abnormal vibrations, temperatures, etc. in the equipment's operation. The static equipment in chemical plants mainly includes towers, containers, heat exchangers, furnaces, reactors, standard valves, pipelines, and so on. During inspection, it is necessary to check the safety accessories, instrument accessories, equipment accessories, appearance, main body and supports, operating parameters, as well as the working conditions of pipelines and equipment. With the digital transformation of the chemical industry, smart inspections have emerged. Robots can collect signals, issue early warnings, and analyze data, detect abnormal conditions, and issue timely alarms, seizing the initiative to address problems. At the same time, robots can monitor key data from many chemical plant pieces of equipment, perform preventive maintenance, effectively extend the equipment's service life, reduce maintenance costs, and ensure the intrinsic safety of the chemical plant. Through today's lesson, we have learned that on-site inspection work is the guarantee of safe production in chemical plants, which, although it may seem ordinary, embodies immense responsibility and value. Every diligent inspection, every accurate record of data, and every timely detection and resolution of potential hazards can prevent a major accident from occurring, and each contributes to the stable operation of the chemical plant. That concludes today's lesson. Thank you all.